Hello everybody, this is our last week on nemeth. Woohoo! Glad you guys have all stuck with it and done a good job. This is Introduction to Nemeth Code Symbols used in Algebra 1, Algebra 2, and Advanced Mathematics. Do remember, I don't expect you to be able to do this math. We just have to know how to transcribe it. Math teachers are a wonderful resource for us to be able to understand it. I am not a higher level math individual, so there we have it. We are starting with the vertical bar, which we also used in last time. We're going to use it also for such that, magnitude, norm, and determinant. We have dot 6 and then a full cell is the infinity symbol. We have 4, 6, and then 1, 3 is the hollow dot. We have dots 4, 5, 4, 5, which is a superscript with a superscript indicator. We have a 5, 6, which is a subscript indicator. Okay, so yes, there is a subscript indicator. We have dots 1, 2, 6, GH, which is index of radical indicator. Let's see, we have grouping symbols, which is 4, 6, 4, 6 of, which is the opening left angle bracket, okay? The 4, 6, 4, 6 with is the opening right angle bracket, okay? We have enlarged grouping symbols. So if these are all like your old other ones, except they have different dots in front of them because they're enlarged. So if you know that of is the left parentheses, then with is your right parentheses, then we're going to get all these others, the brackets, the brace, and the fact that they're all enlarged. Okay, so we have a dot 6 in front of the oven with for parentheses, enlarged opening. We have a dot 4 and then a dot 6 for the bracket and with of and with. Okay, and then we have 4, 6, dot 6 of and with the enlarged opening left and right brace. We have an enlarged vertical bar as well. That is a dot 6. Set theory. So 1, 2, or 4, 5, 6, and a lower J is empty null set. So null set or a 0 with a slash through it. 4, 6, and then an ing, which is 3, 4, 6, is union, which is in print looks like a U. Then a 4, 6, and a SH is called an intersection. Looks like an upside down U in print. We have a 4, 6, dot 5, 1, 3, WH. There's a blank is a subset of, so is a subset of is what that stands for. It looks like a C with a line underneath it. A smushed C. It's that same union intersection, and then it turns to the opening is on the right, or is a subset of. This is the print symbol I'm trying to describe. Dot 4 and 1, 5 is an element of. So it looks like an E. In large uppercase E. All right. Greek symbols all start with 4, 6. We have an A, that's alpha. A B is beta. TH is theta. Dot 6B is uppercase delta. Dot 6S is the Greek letter sigma, uppercase as well. In this chapter, that hollow dot is used as an operation sign representing the composition of two functions. Okay, so that hollow dot we started out with up here is 46CH. Okay? Key points. The number enclosed in vertical bars is used to represent absolute value. The numeric indicator is not used when placing a number between the two vertical bars. The infinity symbol is used to represent that a value continues forever in the positive direction. For negative infinity, the value continues forever in the negative direction. When writing function notation, parentheses are used. When writing interval notation, parentheses and/or brackets are used with a comma between the beginning of the interval and the end of the interval. A parentheses means the value is not included in the interval, and a bracket means the value is included in the interval. We have quite a few of these notes here. So hollow dot is used for degrees and for composition of functions. Single brackets are a type of grouping symbol that most commonly used in math related to vectors. The vertical bar can be used in such that, in set notation, the norm of in vectors, or the determinant of in matrices. Grouping symbols can be enlarged and are commonly used in matrices, determinants of matrices, and systems of equations. Problems involving enlarged grouping symbols are brailled as spatial elements arrangements that will leave a blank line above and below the arrangement. You must have at least one enlarged grouping symbol on each line of the arrangement. You must have the enlarged grouping symbols lined up vertically. Sometimes these must be placed on the top line of the arrangement in the braille regardless of location in print. There are multiple symbols used in set theory, including empty set symbol or null set, the union symbol, the intersection symbol, the subset of symbol, and the is an element of symbol. The union symbol and the intersection symbol are signs of operation, so there's no space on either side of the symbol. The is a subset of symbol and the is an element of symbol are signs of comparison, so a space must be left on either side of these symbols. When an exponent or superscript, remember superscript is up in the sky like Superman, is not followed by a space or not at the end of a line, a baseline indicator is used to return to baseline after writing the superscript. When a superscript indicator or subscript indicator is used, and the superscript or subscript is immediately followed by a mathematical symbol, such as a sign of operation, grouping symbol, terminator, indicator, or fraction line, the baseline indicator is used to return to baseline. No baseline indicator is needed if a space or other level indicator follows a super or a subscript. Do not use a subscript indicator or baseline indicator when a variable has a numeric subscript. The index of a radical indicator is used to show a radical with an index such as a cube root, fourth root, etc. Common functions include sin, cos, tan, and log, and in, regardless of whether there's a space in print between the function name and what comes after it. There's always a space in Braille between the function name and what comes after it. Do not use an English letter indicator in a function. Common Greek letters include alpha, beta, theta, and there are many other Greek symbols used in mathematics. A complete list of Greek symbols can be found in the appendices. All right. Absolute value. We have an example in here. It's considered a grouping symbol. We don't need a number sign inside inside or outside the vertical bar. So we're looking at the absolute value of 5 minus 8. So we do a vertical bar, 5 minus 8, no number signs, vertical bar. Space equals space 3. If two sets of vertical bars are placed next to each other, a multipurpose indicator .5 must be placed between the two sets. Okay, so we have vertical symbol, 5, vertical symbol. Now we have another one, so we're going to do a .5. Then we do the vertical bar 3, or negative 3 vertical bar. Space equals space 15. Okay. So if you want to understand why it's 15, it's because when there's something spaced directly next to each other, it's considered multiplied. So that's 5 times 3 is 15. I don't know why this keeps showing up. Additional uses of the vertical bar. Okay, so we can use it the braces are grouping symbols, is used to represent sets. When a set includes a list of numbers, no numeric indicators are used since it is an enclosed list. The left opening brace is 4, 6 of. The right closing brace is written at the end of the set as 4, 6 with. Okay, so the set is open your set, which is 4, 6 of. Then we have 10, comma, 11, comma, 12, and then 4, 6 with to close the set. And that is read the set with elements 10, 11, and 12. One vertical bar can represent the word such that. In this case, there must be a space before and after the vertical bar in nemeth. The vertical bar is usually used within set notation to represent the domain. Domain range written in set notation normally appear in a set of braces. Okay, so it says this is called the set of all that is X such that X is not equal to 0. Okay, it starts with your brackets, your braces, or curly brackets, whatever you want to call it, is really okay. 4, 6 of, as long as you use the right one. Then we have an X, we have a space, we have a vertical bar, we have space, we have an X space. Remember that not equal to sign? Here it is. 3, 4 goes in front of the equal sign, and that means not equal to. Space 0, then we close those curly brackets, braces. 4, 6 with. Okay. Our next one, we have our curly brackets or braces is we're opening with that 4, 6 of. Then we have Y. Then we have a vertical bar. We have a negative number sign 3. Remember, negative goes on the left side of the number sign. Then we have less than or equal to, which is that WH right after it. Then we have Y is less than or equal to, number sign 3. And then we close with our brackets 4, 6 with. It says often a vector is represented by a lowercase letter. A vector is an object that has both a magnitude and a direction. Picture a vector as directed line segment, whose length is the magnitude of the vector and with an arrow on one end indicating the direction. When the name of the vector is placed between two vertical bars, the expression means the magnitude of the vector. So this is read, the magnitude of u sub 1 equals 5. And here we go. In nemeth, we have a vertical bar, we have the letter u, and we have a 1. Notice we didn't need the subscript because it's a number. Then we have a vertical bar, space equals space, and then a 5. Okay? Sometimes the magnitude of a vector is written with 2 vertical bars before and after, but it still means magnitude whether there's a set of single or 2 vertical bars before and after the name of the vector. So this says the magnitude of v equals the square root of x squared plus y squared end root. Okay, so we have double vertical lines, OU, OU, then we have the letter V. We have the double vertical lines, which is OU, OU, base equals base. Then we have square root x to the second power, so that's a 4, 5, and then a 2. Got 5, we're coming back down to baseline, plus y, superscript sign, and then a 2, and then dot 5 to bring us down, back down to where it's supposed to be, and a closing square root, which is ER. Okay, the letter placed between vertical bars or double vertical bars can also mean the norm of something such as the norm of functions. In fact, a letter placed between vertical bars in mathematics has a lot of different contexts. However, in nemeth code, vertical bars are always brailled the same way as previously described. The number of vertical bars in Braille always follow the number of vertical bars used in print. So we have a G inside of double vertical bars, which is read the norm of G. So there's OU, OU, G, OU, OU. The next one is single vertical bars with an X in between. So it's read the norm of X. So OU, X, OU. Capital letters often used to represent the name of a matrix in algebra. When the vertical bars are placed around this, it means the determinant of the matrix. So we have vertical bar, capital B, vertical bar equals negative number sign. That means the determinant of matrix B equals negative 4. Okay, so again, if this doesn't make sense to you, really what we're doing is just transcribing what we see. Okay? It really is the job of the math teacher to teach this so that your student understands it. And if your student doesn't understand it, they need to ask their math teacher. Okay? So we've got some examples. We have a vertical bar, negative 5. Vertical bar equals vertical bar 5. Vertical bar equals 5. And I like that they put this, they said this, the way it's read is the absolute value of negative 5 equals the absolute value of 5 equals 5. Okay, y equals, and this is absolute value, so that's a vertical bar, 8 minus x, and then a vertical bar, or OU. Go ahead and look through these other examples. This is example 8.1. So we have solve for x if absolute value x minus 2 absolute value is less than or equal to 7. We have the set of all x such that x is greater than 1. We have the determinant of d equals 35, and the norm of f minus h. Okay, so we have all the Braille examples there. Expanded use of grouping symbols. So we have the of and the with, the bracket, of and with a dot 4, and it doesn't want to tell us the brace. The brace is 4, 6, right? Okay. We have 2 open brackets, 3 minus open parentheses, 5 plus 4 close parentheses, close bracket. Here's a number sign. We're going to open the bracket, which is 4 of, not 4 of, and then we have the number 3 minus, then we have a parentheses, so that's just of, and then we have a 5 plus 4, close the parentheses, close the brackets. Okay? Now we have function notation, f of x. Alright, so f of x is f, parentheses, x, close parentheses. Okay, so we have the interval notation, infinity symbol they talk about. So if you remember, infinity is a dot 6 and then a full cell. 1, 2, 3, 4, 5, 6. And we have examples using that in example 8.2. So we have f of x equals negative 3, and then we have parentheses x plus 2 and parentheses minus 4. We have f parentheses x parentheses space equals space. Negative number sign 3, open parentheses, x plus 2, closing parentheses, minus 4. Okay. Notice the only place you needed that number sign was between the negative and the 3. Okay, so we've got other examples where we have the g of x, and we have absolute value number sentence inside of absolute value. We have a set or open interval from negative 6 to 9. It just uses the parentheses. Transcribe it just the way you see it. We have the closed interval from 0 to 8. Then we use brackets on the left and the right. And we have 0, 8. We have the interval from negative infinity to 12, including 12. Okay, so we have a parentheses, a negative, the infinity sign, negative, the infinity sign, comma, which is dot 6, and I'm glad everybody's doing good with that. Then we have 12, and then we're closing a bracket, so it's 4 in width. Hollow dot is 2 cells, 4, 6, then 1, 6. It's used when representing composite functions. So to read f hollow dot g, you would say f of g. So we have f open dot, which is 4, 6 ch, and then a g. Angle brackets is what we in print look like left, which is the less than sign and the greater than sign. It's what they look like in print. But it is not less than, greater than. It is a bracket. So it's 4, 6, 4, 6, and then of. 4646 width. I had to deal with the dog. Okay, example 8.3. We have 135. It looks like degrees. So number sign 135. Then we have a 4, 5, which means it's up in a superscript. And your hollow dot is 46CH. We have h of g of x equals h of g of x. It's written two different ways. It's read the same on each side. We've got parentheses h, hollow dot g, right parentheses, open another parentheses immediately, x, close parentheses, space equals space, h, parentheses g, parentheses x, close parentheses, close parentheses. F of 2 equals -4, open parentheses, 2, close parentheses, plus 3. Alright, so we have an F, open parentheses, 2, closing parentheses, equals -4. Number sign 4, left parentheses, 2, right parentheses, plus 3. Okay, you'll have a couple of other examples. This one looks nice and hairy. We've got open angle bracket 1/2 comma square root of 3 and root over 2 close angle bracket. Yikes, huh? So we've got an opening angle bracket. So we have 4646 of, then we have a fraction. So we open our fraction with a TH. Then we have 1/2 for 1/2. We close our fraction, 3, 4, 5, 6. Then we have a comma. The next one is starts the fraction. Then we have the square root of 3. Yay! And we close the square root. Then we have a slash. And we have the bottom number is 2. We close the fraction, 3, 4, 5, 6. Then we have close the angle bracket, which is 4646 and width. All right. We're into practice. We are on week 8, chapter 8. Your practices are 8.1, 8.3, and 8.5. So you will be doing 8.1 here. The next thing they're going to cover is enlarged grouping symbols. Okay, so parentheses of and with, if you put a .6 in front of it, it's enlarged. So notice here what they've done is that all of the enlarged ones have a .6 right next to the of and with. The fact that it's a bracket of brace or parentheses is further out to the left, or the right if you're doing, well, no, to the left, okay? So it's a .4 to tell you it's a bracket. Then it's a .6 to tell you it's enlarged, and then it's an of to tell you it's the left side, okay? Same thing when we're closing it. We're doing a .4 so we know it's a bracket. We're doing a .6 so we know it's enlarged, and then we've got a width to close it. Okay? Same things for brace. We're going to use a 4, 6, and then a 6, and then the of and the width. The enlarged vertical bar, again, is a .6 in front of the vertical bar, which is OU. Okay, we've got, so here's the examples. Looks hairy, doesn't it? Looks hairy to me. Okay, we've got number 1 is y equals. Then we have this enlarged left brace. Then inside of that, there are 3 different equations. So let's look and see how they did that. This is number sign 1, 4, 5, 6, period. Then we have y, then we have equals. We have an enlarged opening brace. That sits in front of each of the number sentences, and the number sentences are on top of each other. Okay? So the first line mimics the first line in print. Okay? So we've got an opening left brace. Negative x, negative or minus 2, comma, x less than or equal to negative 2. That's the first math problem, or math sentence. The next math sentence is directly under the one above it. Okay, so when you're doing this in Perky Duck, you're going to have to space it over until you get to where these are going to be. Make sure you use tab so that you're not just hitting space, 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 space. Okay? If yours is not set up for tabs, then I guess you're just going to have to space. Okay, so we have the next number sentence has a 4-6.6 of, because it's that enlarged opening brace. Then we have the square root symbol. We have 4 minus x superscript 2. And then we have to do a .5 to bring it back down to baseline. Then we close that square root. We have a comma. Then we have negative number sign 2 is less than, x is less than 2. Your last number sentence in this problem also is part of that enlarged left brace. Okay, so it starts with that. Then we have x minus 2, comma, equals greater than or equal to the number 2. Okay, so we did it. We managed to figure that one out. All right, number 2 says we have a left opening enlarged bracket. It's a lot, isn't it? .4, .6 of. That's going to be in front of each of the 3 numbers listed in the set. So these are sets. So then I have number sign 1, number sign 1, number sign 1. And then we have a left vertical bar. I initially read that wrong. That's a vertical bar. It's not a bracket. And then we have number sign 2. Then we close the enlarged bracket. Okay? We open the enlarged bracket for the next number sentence, or set, I should say. We have number sign 0, number sign 1, negative, number sign 3, vertical bar, 1. Then we close with the enlarged bracket. Okay, so then we've got opening bracket, enlarged, and then we've got number 2, number 1, number 5, vertical bar, number 0, close the brackets. Okay? Alright, so it says, notice that the problem number in the y equals is lined up with the line in the above and below. Okay? So make sure So in the first problem, we got y, x, our equal sign. But we have all of the brackets lined up. I want to make sure that that left brace in number 1 is lined up. Okay. So we make sure that those they should hopefully line up for you. Also notice that they did a heading. They did solve the following problems and then open the nemeth. And when they were done, they did a line and closed the nemeth. Be sure you're doing those directions as well and doing the opening and closing nemeth. Problem 2 was called an augmented matrix. You did know that. I have a cat messing with the window. Okay. We have example 8.5. We have an enlarged opening parentheses. Okay. And this is how it's lined up. So this is where that equal sign is lined up. So we have a plus b plus c equals 2. We've got that here in nemeth. Plus a plus b plus the c's are all lined up. The b's are all lined up. The a's are lined up on each of these number sentences. Okay. Just be aware of that and line them up with your as indicated in print. Okay, so we have brackets, enlarged opening brackets. We have -7, then 5. We have underneath it -10 and 3. So we have the number signs for those all lined up. Closing the brackets, those are lined up. Then we have flat 4. We have a plus, and we have a dot 4, and we have an opening bracket again. We have, so the number sign on this case was not lined up because there was a negative on the top row. So it's a negative plus 4. And then we have a 0 next to it. Again, the number signs are not lined up because the one on the bottom has a negative. So -2. Then we close the enlarged brackets. Okay. The cat is having fun watching the birds, so if you hear my kitty. We have non-use of enlarged grouping symbols. Do not use enlarged grouping symbols in the following situations to cover a fraction. Okay? Because this is a fraction, it's going to go linearly across the line, okay? So it says 2x plus 4 over 3 times 3x minus 6 over 2. So we start with the regular parentheses. We start a fraction with the th. We do 2x plus 4 slash 3. Close your fraction. Close your parentheses. Open another parentheses. Start a fraction, 3x minus 6 slash 2. Close your parentheses. Whoops, close your fractions, then close your parentheses. Okay? If you use a binomial coefficient, again, you don't use the enlarged parentheses. You use regular parentheses and go linearly. Okay, go across the line. So you have a parentheses, 5, then we have SH, which means choose, 4, close parentheses. Okay? It says directly under indicator, which is what that SH is. Okay, remember we used that when we were doing a line over or under. The directly under is that SH. Okay, to write material occupying a large amount of vertical space, such as the square root inside of another square root. So we don't use enlarged symbols for that either. So this says square root, then we have a 4/6 square root, then 125, then we close the little square root and close the big square root. Okay, you're doing, do not do 8.2 unless you feel like you want to. We have set theory, so we have empty set, null set, all that kind of fun stuff. So this you use the brace for the curly brackets, which is 4/6 of, 4/6 with. Another way to write the empty set is to use the empty set symbol, which is a circle with a line through it. That is a 4, 5, 6 and a 0. Okay? Two common signs of operation used in set theory are the union and intersection symbols. Since these symbols are considered signs of operation, there are no spaces on either side of the symbols. The union symbol is written dots 4/6 and then 3, 4, 6. So 4/6 ing. Finding the union of two sets is like uniting them or putting them together so that all the combined elements are in one set. Oh, you get to hear all sources to go. Sorry. The intersection symbol is an upside down U in print. It's a 4/6 SH. Or it looks like a cup, really. Turned upside down. The opening is on the bottom. It has a teaching tip to think about. It's upside down, so it's a 4/6 SH. And the union is 4/6 U. So if you think about them flipping up and down, so the opening is up is U, opening is down is SH. So there, that SHU is flipping up and down. If that's helpful. Takes 4 cells to write is a subset of. Okay, so this is that opening cup, and it's opening to the right, and it has a line under it. Okay, so it is 4, 5, 6 dot 5, 1, 3 WH. Okay, it takes and note that it does have uses that less than or equal to sign. And it just uses a 4/6 in front of that. Is an element of is it looks like a print E in capital in a strange font. So it is a .4 and then in E. Example 8.6 follows 8.3. You need to do 8.3 practice. Okay, so we've got A union B. Capital A, 4/6 ing, capital B. Then we've got the set with elements 1 and 3 union the set with elements 2 and 4 equals the set with elements 1, 2, 3, and 4. Okay, let's see what we got. We've got a brace, 1, comma, 3, closing the brace. Union, which is 4, 6, ing. And we've got the left brace again. We have 2, comma, 4, close the brace. And then we go down, right, equals, space, and we have the brace opening, 1, comma, 2, comma, 3, comma, 4, and then the closing brace. Okay? Okay, so we're still in example 8.6. We have a null set in the third example. We have a subset listed in the fourth example. We have an open or null set, it looks like. So they just used, notice they just used the braces with nothing in between them, opening and closing brace. And then we have that subset of, which is 4, 6, and, 4, 5, 6, less than underneath, a line underneath, which is WH. Then we have an opening brace. We have capital A, comma, capital B, comma, capital C, comma, capital D, and close the brace. Okay? So, just on 8.3 is assigned. So, I think you guys probably got the hang of it by now as to when you're Braille and when you're using print for me. Okay, remember to label things for me. We have a review of superscripts and the baseline indicator. That should be relatively self-explanatory. We've got a squared plus b squared equals c squared. So we've got a superscript 2, then a dot 5 plus a b superscript 2, so that's b squared equals p superscript 2. Okay? Expanded views. So we've got the f of x, we have f to the -1. So we have an f superscript -1.5 to bring it back down, parentheses, x, close parentheses, which is read f, the inverse of x. Okay. We have, if an exponent is raised to another exponent, the superscript indicator is used twice instead of once before the second exponent. So we have e, superscript x, then we've got 2 superscripts with the 3. Then we have the time symbol, which is the dot, which is a .5 ch. Then we have 3x superscript 2. Okay? We've got subscripts now, which is 5, 6. Okay, so remember that if the subscript is a number, you don't need to use a subscript sign. So we've got the very first example is y minus y1 is m parentheses x minus x to x1. xx1. So we've got a y minus a y and then a 1 right after it. Okay? We've got an equals, then we've got an m, parentheses, x minus x, and a 1, which is like a subscript. Okay? Many chemistry formulas contain subscripts. Okay, the numbers appearing as subscripts in the chemical formula indicate the number of atoms of an element. So we know C6H12O6 is actually fructose. So we've got capital C with a 6, no subscript sign, capital H, 1, 2, then we have a capital O and a 6. Notice there's no space, no spaces, because there's none in print. Okay? We've got log 3 is x, log 3x, base, log base 3 of x. All right? So log 3, base x. Okay? A sub n equals A sub n minus 1 baseline plus 5. So we got an A subscript n. So we did need the subscript sign because now it's a letter. Okay? Equals A subscript n minus 1. Dot 5 brings it back to the baseline plus 5. Okay. Example 8.7 has a lot of these examples. Oh, they look nice and hairy, don't they? We got S sub n equals open fraction, a sub 1 open parentheses 1 minus r to the nth power close parentheses over 1 minus r close fraction. Can we tell, right? Capital S, letter sign N, or not a letter sign, it's a subscript N, sorry, equals, open your fraction, and we've got an A with a subscript 1, so we don't need the subscript sign. Then we have a parentheses, 1 minus R, superscript N, bring us down to baseline, close your parentheses, slash, now we're doing the bottom part of the fraction. 1 minus R, close the fraction.